Hello everyone, welcome back. We're going to continue to talk about sampling distribution. After last time, hopefully you got a little bit of an idea about what we're trying to talk about here. Okay? It is one of the most important subjects in this course, in my opinion, and also probably one of the toughest at the moment that you're coming to it. So do take a lot of time to make sure you're understanding what's going on. And if it's confusing, by all means, contact me early, not late. Okay? So when you're confused, contact me right away, not right before the assignment is due or right after the assignment is due. Okay? All right, anyway, there's my lecture. So a sampling distribution, which we started to talk about in the last video, is a mathematical model that describes the behavior of a statistic. So last time I said it is a mathematical model that describes a random process, but it describes a special one. And the special part is that it describes a statistic. And so we're going to focus on two statistics in this class that we're really interested in. So really, we're only going to be talking about two different sampling distributions. And it's a sampling distribution for the sample proportion, p hat, okay, and the sample mean, x bar. So in these cases, I'm in the sample proportion, I sample a number of people, and a certain percentage of them or proportion of them answer in one way and the other people answer the other way. And so I'm looking for the proportion of people who said something or feel some way, so on and so forth. Okay, and then in the sample mean, I'm taking a sample and then finding the mean of some characteristic of that sample. Okay? All right. Here's a preview of coming attractions. It turns out that under certain conditions, the sampling distribution for both of the statistics, p hat and x bar, are going to be normal. Okay, so the reason why we focused on the normal distribution in lesson 4 is that we're going to be using it throughout the rest of this course, okay, and especially in the coming lessons. Okay, but it turns out that both p hat and x bar, the sampling distributions of p hat and x bar, are going to be normal. Okay, each of them is going to have their own mean and standard deviation. It's going to be a little bit different for each of them. They're going to have their own formulas and so on and so forth, but each of them is going to have a normal distribution. So we're going to start off talking about the sampling distribution for p hat. Okay, so what we're going to do is we're going to describe that mathematical model that governs how a sample proportion behaves. Okay, so when discussing the sample proportion, we have a situation where the survey is asking a yes or no question. Okay, and so to understand this situation, we're going to need two numbers. Okay, or symbols. So these are the symbols that we're going to be working with when talking about a sampling distribution for p hat. The first one is the population probability of success. So for these questions, we're going to need to know overall what the probability of success is. So for instance, if we were talking about that coin example, we're going to have to know that a fair coin has a probability of landing heads 50%. That would be our probability of success here. Okay? But in statistics, a success may not be something that we think is a success. Okay? It may be the goal of my survey to see how many people died from lung cancer, and then so the probability of success there would be passing away. Okay, of course, we wouldn't think of that as a success or good in any way, but success does not necessarily mean a good thing here. Okay, and then we're going to need the sample size. Okay, so we need two things: the probability of success, p, and the sample size, n. Okay, so in my coin example, in the previous video, we were flipping a coin 10 times at the beginning, and so that would be my sample size. Okay, and so here here is the mathematical model that we're going to use to describe p hat. So under certain conditions, the sampling distribution of p hat is approximately normal. Okay, so it turns out that the distribution of p hat is approximately normal, and specifically it looks like this. Okay, so I start off on the left side with p hat, okay, and then there are two squiggles in the middle. That means approximately normal. We really aren't going to worry about that, but I just put it there for my own satisfaction, because if I had something else, I would cringe too much. Okay, so p hat is approximately normal, so that's what the n means. And then inside the parentheses, you remember that the first thing is the mean, and then the second thing, or the thing to the left of the comma, is the mean, and the thing to the right of the comma is the standard deviation. Okay, I'm not going to begin to talk about where these numbers come from. There are mathematical derivations that we could do to understand why they are what they are, but I don't think you'd be interested in hearing them. So I'm going to skip over them. Okay? The mean is p, and the standard deviation is the square root of p times 1 minus p divided by n. Okay? So the mean is p, standard deviation is that. So that is the mathematical model that describes p hat. And so if I ask you a question about p hat and I ask you a probability question, you're going to use the normal mathematical model that I have here, okay, to answer those probability questions, just like we did in lesson 4. Okay, so before we move on, there are a few caveats that I have to talk about that are really important when it comes to the sampling distribution of p hat. It turns out that the previous slide is only true when certain conditions are met. So if you noticed, every time that I talk formally about the sampling distribution of p hat, I always add a preface. And the preface is under certain conditions. And so I've said it again here. So what are those conditions? So as we saw in your turn activity, when you worked with that applet about flipping the coins, okay, hopefully you saw that the distribution of p hat wasn't always normal. Okay, it wasn't always symmetric. Sometimes it was skewed, so on and so forth. Okay, and hopefully you found that it was especially not normal when the probability of success was far away from 0.5, okay, far away from fair, and or n was low. Okay, and so you saw it was worse when p was greater, when p was far away from 0.5, and when the sample size was low. So the conditions that you need to meet in order to use the sampling distribution, and what I mean by this when I actually ask you about problems, is that you need to check these conditions before you can use the sampling distribution. Okay? If these aren't met, you can't do the problem. Okay? The conditions are these two things. Okay? The sample size times the probability of success needs to be greater than or equal to 13, and the sample size times 1 minus p, which is the probability of failure, also needs to be greater than or equal to 15. Okay? When both of these conditions are met, then you can say that p hat is approximately normal, blah, blah, blah. Okay? Again, for reinforcement, they need to be met. And so if they are met, we can use the sampling distribution to begin to answer those questions posed at the beginning of the lesson. Okay? And so we can start to say with some certainty what percent of people go to the beach, or are flipped classrooms effective, so on and so forth. Okay? So here's an example. So probably up to this point, you are confused, and I understand. This is a tough thing to talk about. It's a tough thing to learn, but it is important, and hopefully this example will give you some clarity about what I'm trying to do. All right. And so I'm going to go back to coin flipping because I think we all understand coin flipping and we can gain some insight about what's happening. So suppose that I flip a fair coin 50 times. And I put here, just as a hint, that a fair coin means that the probability of success is 0.5. But I think we know that. But just to make sure, I put it there. Suppose I flip the fair coin 50 times, and I'm interested in the number of heads. Okay. So this is a question that I will ask you often. Okay. I give you a situation, a setup, and then I ask you what the sampling distribution of p hat is. All right. And what I want you to do when I ask this question is simply go back to the previous slide, or maybe 2 previous slides now, and look at the normal model. When I say in symbols, p hat is approximately normal with a mean of p, standard deviation of the square root of p times 1 minus p divided by n. Okay, that whole big long thing, all I want you to do is substitute in n and p. Okay, so I substituted in n and p. Okay, that's all I did. P is 0.5, and 1 minus p is also 0.5, n is 50, and so when I do that, I get, and I do the math, I get that p hat is approximately normal with a mean of 0.5 and a standard deviation of 0.071. Okay, this governs how a fair coin being flipped 50 times behaves. Okay, it's going to give me specifically how the proportion of heads behaves. Okay, now before I can say this, I really need to check my assumptions or check those conditions that I needed to do. So before this is true, I need to check if n times p and n times 1 minus p are met. Okay, and so 50 times 0.5 is 25. Okay, great. That's greater than 15. And then 50 times 1 minus 0.5, and 1 minus 0.5 is also 0.5. Okay, 50 times 0.5, or 50 times a half, is 25. So both conditions are met. I can move forward and use this sampling distribution. Okay, so I meet the conditions here. Okay, 50 times 0.5, 50 times 1 minus 0.5. They're both greater than 15, so I can move forward. Great. So these first 2 steps, writing the distribution out, meaning this step, okay, and meeting the conditions are the answer to this first question. All right. Then I'll give you a second question. So, given that the coin is fair, what's the probability that I see at least 30 heads out of 50 flips? Okay, and so my hint is 30 out of 50 is 0.6. So, oh, excuse me, I need to go back and I need to answer this on the fly. Okay, so I want to find the probability that p hat, which is governed by this rule, 0.5 and 0.071, okay, is governed by this rule. How likely is it that I actually see at least 30 heads out of 50 flips? So I'm going to go now quickly, StatCrunch. I'm sorry I didn't have it already. It'll be just a second if it doesn't error. So it turns out that it errored. A number of you have seen this error before, and it's quite an annoying error, okay? Because I can't go any further. But I will be back. I will, in a separate video, answer this question with StatCrunch. Okay. In fact, this question. I will answer this bottom question in a separate video when I have StatCrunch already working. Okay. But for now, we found the sampling distribution of p hat, and we can actually use that distribution, just like we did in lesson 4, to answer that question. All right? So here's the reading assignment to try to understand a sampling distribution a bit more, and then I have a your turn. Okay? So in this your turn, I give you basically the same type of setup that I did in that last problem. Okay? At a university, 60% of the 7,400 students are female. The student newspaper reports results of a survey of a random sample of 50 students about various topics. What is the sampling distribution of p hat? And then what's the probability that I would see at most 26 females out of 50 respondents? Okay? And so I want you to answer this question just like I did in the last slide, but of course you actually have to answer the probability question. I'll see you next time.